Let's write inverse functions for rational functions this time. The steps are the same. We're going to replace this f of x by y, change that to y, and keep everything the same. 8x minus 9 on top, and x plus 3 in the bottom. Now, step number 2, remember, we need to replace the y's by x, and all the x's need to turn into y, right? So let's do that switching. So on the left side, we're going to have x equals no more y. And what's going to be the numerator? No more 8x minus 9, but 8y minus 9. And in the denominator, not x plus 3, but y plus 3. So we really just switched all these highlighted terms to x and y. Now, this is what we have to solve for y. Go ahead and multiply both sides by that denominator. See, if I multiply both sides by that denominator, we're not going to have a fraction anymore. Because look what will happen here. I can just cross out this y plus 3 and this y plus 3. Okay, so the right side of this equal sign is not a fraction anymore. It's going to be 8y minus 9. Now we're going to distribute this x in. If you distribute, you will get yx plus 3x. Now, here, what we will do now is gather all the terms that have y to the left. And if it doesn't have a letter y, we're going to send it to the other side. So let me go around and see which terms need to move. This has a y on the left, a y on this term, so I'm going to keep it here, okay? But notice the 3x doesn't have y. I'm going to send it to the other side. Go to the other side. I'm only keeping the terms that has letter y on the left. Now look at this one, 8y. See, this has y, so I need to move it to the left side. So it's like I'm calling all the terms, hey, if you have y, come to the left side. If you don't have y, go to the other side, okay? So this is the plan, and this -9, you see it doesn't have y, right? So keep it there. All right, let me see what happens. This yx remains the same, okay? This 8y used to be positive, but when I move it to the left, this is now negative. Okay, draw the equal sign. Now, here comes this 3x from the left side, but it was positive when it was on the left side. So if I move it, that now turns into negative 3x. And you just have to bring this -9 down. Okay, and what was all that? I did it so that I can gather all the x's, I'm sorry, not x, y's to the left side. Because now notice, this term has y, this term has y, so I can factor out the y. So write that y outside once. We're factoring out the y, and we're going to write down the leftover inside. What's left when these green highlighted y's get factored out to the front? You have x left, and you have -8 left, right? So we're going somewhere. This is good. So the right side stays the same. But now I want to get rid of this parenthesis, this 8x minus 8, that is multiplying to y. So what's the opposite of multiplication? We're going to now divide both sides by 8x minus 8. Divide this side by x minus 8. And I did all this. so that I can just cross out this x minus 8. And the only thing that we have left is y equals, I'll move this a little bit to the side, y equals that fraction, negative 3x minus 9 over x minus 8. Now the last thing is to replace this letter y with the inverse name, right? So what was the name of this function? This guy was called f of x. So we're going to say what we just found is the f inverse of x. And that is how we find an inverse of a rational function. But let me see if they ask you to find the domain of these. I don't think I read the direction yet. No, oh yeah, they did. They said state the domain and range of this inverse in the interval notation. So we'll do that. Okay, I'm gonna move this to the side a little bit. Okay. Domain is easy. Okay. Domain of this inverse function is super easy. Remember, domain of a rational function is all real numbers except for the number that makes the bottom of the fraction 0, right? So look, the bottom of the fraction has x minus 8. X can't be equal to 0 at 8, right? Because if x is 8, 8 minus 8 will give you 0 in the denominator, so that's not allowed. So the domain is going to be everything except for 8. So this is what it will look like in a picture. Everything to the left of 8, everything to the right of 8, but not 8. So how do you write that in interval notation? Negative infinity to 8, union 8 to positive infinity. Now for the range, I'll show you a trick, okay? You can find range of a rational function by going back to the original function and looking at its domain. Because when you write an inverse function, remember we switched x and y, right? So domain and range got just switched, right? Because domain are the x values, range are the y values. So when you switch x and y, you really just switched the domain and range. So go back to the original function and let's try to read the domain of this function. Domain of the original function. Well, if you look at the denominator, you get that, oh, x can't be equal to negative 3, right? Because if x is negative 3, those opposites will add up to 0. So you're looking at a domain where you can have everything to the left of negative 3, everything to the right of negative 3, but just not negative 3. So how do you write that in interval notation? Negative infinity to negative 3, union negative 3 to positive infinity. And guess what? This used to be the domain of the original function. But when you wrote the inverse function, this right here just became the range of the inverse function because what used to be x is now y, right? We switched that x and y. So what I'm going to do is I'm going to copy this and just say that that is the range of the inverse function that we just wrote. So that's how I would just find the domain and range of the inverse function. Now I'm going to show you something else here, okay? Not only this green part that I wrote is the domain of the inverse function. Nobody asked me this on this problem, but what if I want to find the range of the original function? It's just going to be the domain of the inverse function. So we can find it just like that. But this was one example of writing inverse functions for a rational function and stating the domain and range of that in interval notation.